To call a discipline like architecture living is a rather precocious thing. How on earth would we make something which is inert, which is artificial, into something which we could associate with the world of nature and the world of life? What we do is we work in quite practical steps which are intensely bound in craft. We start with scaffolds and we make them resilient. We make them things that can be woven in to computation. Multiple meshes of microprocessors control and feedback with arrays of sensors and mechanisms, actuators, and all of those things together also work with liquid metabolisms as well, taking chemicals that can modify the environment and exchange. All of those technical systems then are woven together in a way that is deeply empathetic, that depends on human experience, and that fosters conversations back and forth. And so in the end, while the work is intensely technical, it also is founded on a kind of philosophy where we're seeking mutual relationships with the world, being among, being interdependent, even being unapologetically fragile, rather than trying to command and control and govern. Today, one of the dimensions we're working on focuses very specifically on integrating electronics with the structural systems that I've been describing, the kind of resilient scaffolds. A rather traditional relationship of electronic controls with structures is that of a cluster, let's say the same kind of thing that we have in our cranium, separate from our body. What about if instead of those kind of consolidated, powerful groups of controls, we could think of a kind of environment as having a whole meshwork where many, many different nodes are all speaking to each other? We've started to look at the way nature works in wetlands, or the way deep filaments intertwine in a mycelium, that is a mushroom root network. And that translates into a wish to find a new kind of electronics, rather than concentrated printed control boards, which make strong, strong nests housed in encapsulation. We're looking for ways to take very small, gentle elements and distribute them, along with very lightweight cabling. And so we might have, rather than moving from these rather modest microprocessors and their shields and their modifications, we're very interested in moving with increasing miniaturization into elements that can be directly integrated into mechanisms. And so we're quite excited about the possibility, this is just a prototype board that we've just developed, about integrating some quite meticulous detailing into the board itself. Elective circuitry that we can quickly go through multiple prototypes with, and then at the same time, right alongside the interest in circuitry or in electronic hardware, look at the kind of strain relief or the clipping or the cable mounting, perhaps even going into soft substrates so that this then could move and shift. Trying to find things that are finger-friendly, that we can participate in and work with, but at the same time be kind of radically dispersed. For many years, we've made our own boards by designing them and sending them out. We've also worked with muriatic acid and garolite and burning traces in, and we've worked with prototype boards, breadboards. But what we haven't been able to do is directly kind of find the kind of cycling, day to day, hour to hour, that would be possible with a fabrication machine. This is not the same kind of electronics as we might pursue in microelectronics, where they become immaterial, where they become so compact that they stand aside from human manipulation. We're interested in very, very tangible things that a group of school children or a large group of volunteers could assemble together and then reconfigure and find again. And so this ability to work now with some custom making of boards directly interwoven, have very particular ways that they can be configured. This is a tremendously motivating space. It's been a dream, and it hasn't been available to us until just this year in a new partnership with VOLTERA.